What would happen if this YouTuber fell off a cliff while doing math? If you haven't seen the viral video of this YouTuber, Michael Penn, hanging off of a cliff while doing a Calculus 2 problem, I strongly urge you to go watch it. It's crazy. He solves a math problem while he's quite literally hanging off a cliff. He's a very, very skilled rock climber, and he does a math problem at the same time. Go watch it because that's what this video is going to be based on. But my question today is, how much force is needed to hold him up against the cliff if he was just sitting there himself without adding any extra force? How much force is on those cables when his body is just hanging off of the cliff? So let's get into it on the chalkboard.
So here I have a rough sketch of what I'm talking about. We have our little Michael Penn hanging from the cliff, and we have him holding his whiteboard and this tension cord here that's holding him up against the cliff. If he was doing this math problem just with both hands, not hanging by anything but the cord, how much weight or how much force would that cord need to support to keep him from falling to his death down the cliff? So let's jump into the problem. First, we know that Michael Penn is about my size, so we'll say that he weighs about 160 pounds, which is also about 700 newtons. So that's where we'll leave his weight at here. And we'll say that combined with the whiteboard, them together make up about 725 newtons. Dr. Penn, I'm sorry if I'm overestimating your weight here. Okay, but now we need to figure out how much force this tension cord can hold. Well, it's pretty simple, because if we draw a free body diagram, and this dot we'll say is Michael Penn, then the downward force of gravity has to equal the upward tension force. And so our downward force of gravity is 725 newtons. So that means that these two forces are equal if Michael Penn is not falling to his death and is in fact suspended in midair by this cord. So that means our force of tension here is 725 newtons. If this tension is less than 725 newtons, or if this cord can't take that much stress, then Michael Penn will indeed fall and splat on the ground down here, which we'll go ahead and calculate on the next board. So let's suppose that the cliff is 20 meters tall. How fast will Michael be falling when he hits the ground if this tension is less than about 725 newtons, which means the cord will snap and Penn will fall down the cliff? How fast will he be falling when he hits the ground? So we know from introductory physics that we have two equations here. First, we know that the final velocity is going to be equal to the initial velocity plus the acceleration times the time. Well, we know that this is zero, this initial velocity, because he's falling from the cord snapping, from which he was falling at a rate of 0 at that point. So our v0 here is 0. Our acceleration is gravity, so I'll go ahead and note that over here. But our time is unknown. That's what we're going to need a second equation for. So our second equation is going to be h equals at squared plus v0t plus h0. Where h0 is our initial height and h is our final height. But because we know that h0 is 20, because we start at a height of 20 meters, and h is 0, our final height will be 0 when it hits the ground, we know that we have negative 20 over here. This v0t goes off to 0 again because we don't have an initial velocity, meaning that we're just left with negative 9.8 times t squared is equal to negative 20. Rounding this a bit, we'll find that t is about the square root of 2, just a little bit over that. So if we plug in the square root of 2 here into our first equation up here, but that means Michael's final velocity as he hits the ground is going to be negative 9.8 times the square root of 2, or 13.58 meters per second going towards the ground. That would hurt a lot. I think that's enough for now.